Oh, well, yes, it's not on, okay? What I have learned is I messed up on my hole locations. These brackets, this end of the bracket adapter are different. This one is actually inverted, or at least it looks inverted. This one has the flats on top. This one has a flat on the bottom, so the holes are offset. Here they're offset down, here they're offset up. So I'm printing a new bracket. I can't do anything with it. I did just set it there, clamped it, and touched it, and it does move the Y axis. I can't do any calibration with it until I get that bracket because nothing is screwed together. So I'm just like holding it with my hand is all of my strength, and it moved the Z in and out. It did. I can't do it with a phone and all, but so we have this guy going up and down great, this guy going back and forth great. This guy will go back and forth when I get a bracket that I can bolt in and tighten everybody up, and it will work. And it's not going to happen today. It's 4:15, and this thing takes over 2 hours to print. A lot of support goes into this, and it's a pretty dense part, so it's just the way it is, okay? I can't get over how well it works. So I mean, the minor sag really, it's a heavy motor, but apparently this aluminum is pretty strong, and I'm really not going to be doing. I'm going to work mostly over in like this area because, you know, here's the part. Get it out of this vise if I can. There we go. This is the part we're going to be machining, and that's the area we're going to be machining. We're going to machine a slot. I tried to do it by hand just as an experiment. This is an old broken one, don't worry. So it's going to get clamped down like that, and then all we're going to do is a slot. Oops, I'm so sorry. We're going to clamp it in like that, and then we're going to put a slot in right there so that it mimics. Not really. This is one I had done for me outside, right, Jim? So we're going to do that here, I think. We're going to try it. And we'll look at other things also. So that's going to clamp. It's going to make that slot. And with that slot, like on this one here, it does not have it. You'll see. This is a full chassis with a reverse and boiler, right? No slot, no hole there. So we're going to make one. And when we're done, the slot's going to look like that. Okay? Except it won't have this boss, all right? To hold the smoke gear. But it'll have that slot. And with that slot, I can put in my adapter that I built for this engine that has the smoke gear hanging off of it. And it bolts onto my, you know what, right? Yeah, my favorite things. Are they in the right? No, this way. Okay, they go in like this, or do they? I'm all turned around today. Okay, I think they go in like this. Yeah, try that. I can't do it with one hand backwards and eyes shut and all that. Okay, there we go. There we go. We had it. We had it. Anyway, it'll bolt on top of that, and it'll run across. Have a gear hang down. Did it again. It bolts on top of that, runs across, has a gear hanging down, and then on that are switches, two switches, one for puff and chuff, and one for, one for smoke and one for the chuff sound. Then it runs back to the board, and that sends a signal back to the smoke assembly, which you have seen. It's a 3D printed smoke that fits on here, clamps on. So this is the only hole you're going to need. We can put on puff and chuff smoke with sounds and all kinds of stuff. Now this is one we tried to do bushings. May come back to that, don't know yet. This one seemed to have trouble getting things square, but there's other ways. I think I can give it a shot with this tool. I have a way of making, I can do it, there's a probe, they call it. So I can come along here and I can probe this edge, and I can make sure it's perfectly linear with the drill bit. Then I can come along and open those up, push in a brass bushing or bronze or roller bearing, and should be able to do that. Now, the other thing we talked about, this is a little far out. This is a little far out. I mean, far out. Don't go nuts when you hear this, but what if we cut this off right here? Cut it off My finger's in the way. What the hell? Cut it off along here. Just cut it off. Just cut it off. And then open these up like this. Then, so it looks like this. All right, then have a ball bearing on a shaft, another ball bearing on a shaft, have a wheel, and just slide them down in there. And if you needed the drive gear, you press the drive gear on, put the wheels on, slide that down in there. Then you flip this over, you got lots of meat in here, zip, 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 put in some holes, and you 3D print a lower chassis adapter that clamps those wheels in and gives you clearance for everything else. So you go screw, 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 boom, it's together. I think that would be pretty awesome, frankly, if we come up with that. So you could have the slot, you could have roller bearings in the motor, DC fields. My God. Well, that's what we're doing. Then we run out of these guys, or we run out of, where is it? This old bugger, yeah. We run out of these. I happen to have about 10 or 15 of them, but there's more out there. I know a friend of mine has a box of them for me, a stinker. Anyway, that's the direction. I'm talking now because I'm printing, and it's so frustrating. I could kind of walk you through, I don't know if this is interesting. Andy has been my life's best friend, savior. He knows, he finds this stuff and then drags me into it, kicking and screaming. Not really. But this is called, I don't know what it's called. It's something. Let's see. Where do I get it? Let's see if it's here. About. Yeah. Universal G-code sender. Now, sounds like a lot of stuff, but it's not a big deal. It's G-code, which is machine instructions. We've known that for a long, long time. G, something, and you go do it, okay? And then sender is you sends it to things, and then universal means it can send it to more than one thing. And what we're doing, as you may know, is we're building this with a Uno from Arduino, which is the hobby microprocessor, basically. And it's been engineered with a shield. They call these shields because they sort of just sit on top of them like a shield would sit on your arm, and then you can do more with it, I guess. But this, if you can read the fine print, this is a CNC shield. Oh, I left this on. Dumb, man. Okay, there we go. This is a CNC shield and computer numerical control. What does that mean? Wow. That means you can send a pulse from here. You can create a G-code, which means, let's say, for example, X plus 20 millimeters. Moves the X-axis to the plus direction, 20 millimeters, if it has enough room. Well, switches on here eventually. But it would then go, if you send that, it would go, and it would stop. And the same with the Z up and down and the Y in and out. You can send those commands. You can send them in a string. You can send them in a program. You can send them one at a time and do your alignment kinds of stuff. You can do testing, all that crap. Now, for our case, we want to make a slot, right? We have a flat piece of metal like that. And we want to put a square opening that goes down like this into the cavity. So we want to take this cavity design, you might think of it as a hole in the air, and we want to take that hole in the air and we want to set it here, and we can like mark, here's the start spot, right? Mark this to start. And we have the part there, and we've measured, we know we have it in the right spot, and it's clamped. The tool is sitting there ready to go. Ringer, 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 let's go. And you say start, and you say, if this is what you want to do, this program looks at what you want to do, and it says, oh, you want this thing, and you want it this deep. Okay, so we're going to make let's say you want it 10 millimeters, real thin. And we're going to make 1 millimeter passes because you told us to do one only. And we're going to do it to this shape. So we're going to start here. We're going to go like this, and then we're going to end. Then we're going to jog in and do this shape. And we're going to do that, and we'll do that. And then we're done. And that's layer 1. Then we go with our Z. We go down to 2 millimeters, and we do it again. So now we have a 2 millimeter bite of this shape that you want. And we do that 10 times, and that gets us down to the 10 millimeters, taking a millimeter cut at a time with this cutting tool that I cut my finger on. So you got to be careful with them. I took them out. And that's how you do that. So I could take my part, clamp it onto the tool, align where I want this real accurately. I have things to do it. I have probes, things like that. Then you take the program that you want and you start it here, and the tool bit's there, the part's there, everything's ready, and you just say go. And 2 hours later you come back and you have a slot. You got to clean up all your chips and wipe it down and deburr it and take it off, and it's done. Then you clamp another one, align it, hit the go button, come back an hour later, and it's done. Oh yeah, I'm excited. This is going to be exciting. This is going to be a lot of fun. And none of us are taking our clothes off. This is just fun with your clothes on. It's fine. It's all good. You can do it together. It's fine. And the motors sound excellent. The motors sound really nice. We worked out the schematic a couple times. Jeez. Got that. I worked out my dimensions for calibrating. Andy gave me some tips on that. We got we have these two just dead on. They go. You say, I want 25 millimeters. You measure it. It's 25 millimeters down the pike. Absolutely perfect. This one we have to do that yet, but I know how. I've done it enough times. It's fine. Everything's fine. I want to get that bracket. It's printing. Yeah, it's printing. I just set this up trying to get the depth of the clamping and make sure that that was okay, and that the motor would turn with everything in there, and it does. So I think we're going to be fine with it. And I'm all excited. I'm so excited, and I'm so frustrated at the same time. I thought the brackets, I didn't really think, all right, I just assumed the brackets were the same. You flip it over, you bolt it on. Doesn't work that way. They goof up. They change their minds. Anyway, that's what's happening. It's great. I think it's going to be super. And this product, if you look at it, it's really cool. If you look up this CNC shield, it's really cool. This board, Uno's you can get. There's an R3, there's an R4 if you have money. And these little chippies here are what's called a A4988 stepper driver. I mean, it sounds like a lot, but it's not. These are not. I don't know how much they are, but they're not money. They're not a lot of money. And I have 3 here for X, Y, and Z. Now, if I had a 2-motor Y, some beds do, or Z, you can put in a mirror chip that mirrors the motion of everything else that you have to do. But if I wanted, I could change this program slightly, and I could run the speeds and feeds of my cutter. But since I'm using the Dremel, this is my first one, low end, cheap. You know, I already had this, boom, 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 printed part, you know. I'm going to just do with what I have. I'm going to turn it on and set the speed, and then bring it into position, and then hit the go button and take off. There's some good stuff going to be happening. I'm pretty sure. I mean, the way it worked, unless the cutter, you know, can't handle it, or this guy can't handle it. This is a pretty meaty thing, but you know, we can always make them different and improve them. There is a different motor you can get for this thing that's like rip your arm off if you got caught in there. So you gotta be careful. This is a real machine now. Or will be. It's called a mini mill. It's a CNC mill, but it's real tiny. It's like not a toy, but it's like certainly a hobbyist thing. I mean, I'm a hobbyist, right? I don't do this for a living. I'm just having fun. It's going to be okay, I think. All right. All right, wait for my part. Get back on it. I'll fill you in. Sorry about the break. Later.